I'll just introduce you, then you can take over.
Oh, sure.
Uh, so, good evening and welcome to our webinar series Dwell in Drupal 8. This is a flagship initiative organized by Unity Solutions. Unity Solutions is a software development company with specialization in Drupal development services. We use open source technologies such as Drupal CMS to build robust, cost-effective solutions and cater to industries like publishing, education, e-commerce, finance, and many more. Being one of the pioneers in India to adopt Drupal, we are very happy to cherish our journey with Drupal through this webinar series, Dwell in Drupal. Today's topic is Drupal caching improvements in Drupal 8 by Piyush Kumar. Piyush works as technical architect at QED42. He has been into Drupal for past 6.5 years. He's a passionate Drupal developer and credited on with 31 issues fixed in the past 1 year and 281 commits. Piyush also attended many Drupal events, Drupal Camp Mumbai being the latest. Also, he mentors newcomers in Drupal community. Apart from professional life, he likes reading, traveling, and playing online games. Piyush, thank you so much for joining us and welcome to our series.
Thanks, Jaya. Thanks, Jaya, for the introduction. Thanks, Unity, for giving me the opportunity to speak around Drupal 8 caching. And welcome, guys. So today we'll be talking about how caching layer has changed in Drupal 8 completely. We'll also see what were the caveats in Drupal 7 caching mechanisms and how Drupal 8 has come over them. About me, I work as a technical architect at QED42. I'm a Drupal 8 developer, trainer, and contributor. You can find me on Drupal.org with this name, Piyush23. And as Jay already mentioned, I love traveling, reading, and internet gaming. So yeah, I'll quickly browse you through the topics. We'll see what were the caching limitations in Drupal 7. Then quickly go through the terminologies which have been introduced in Drupal 8 around new caching techniques, like cache tags, cache context, cache bins. We'll also see how Drupal 8 internally invalidates cache automatically. We'll also see how to configure or how to make reverse proxies work with Drupal 8 correctly. Towards the end, we'll talk more around how or what was the caching architecture in Drupal 8 that helped bring in modules like Bigpipe in core. Okay, so we're good to start. So let's start with the caching limitations in Drupal 7. So the very first limitation was around rebuilding the content each and every time, even though it was not needed always. So as you can see on the screen, the three screenshots showing you three different pages. The first one being the home page, the second one being a node page, and the third one being a view page. If you take a look at the area highlighted, it's rendering the same content. The same node is being rendered in three different places, right? But ideally, what should have been done, the content should have been rendered for the first time and cached in the database. When it was requested for the second time, it could have been pulled from the cache. But in Drupal 7, in all of these three cases, the data was getting pulled every time from the database. That's one of the problems, which was solved using one of the contrib modules, render cache. Now, this is the module which became the primary layer or primary idea behind the caching system in Drupal 8. By the way, this module is being used by Drupal.org to render a lot of comments on issues. This setting, I think every one of us would have seen this setting, but let me talk about a scenario here. Okay, let's say you go ahead and enable this setting on your website. Okay, and then you go ahead and browse a few pages, like let's say there are 10 nodes on your website. You go and browse node 1, 2, 3 up to 10. Your page cache has been generated in the database. Now the next thing that you do is go ahead as an anonymous user, add a comment on one of these nodes. Ideally, we would expect the cache for this node, this specific node, to get cleared, right? But what happens is Drupal will clear all of the page cache. So this is what happens. So let's say I browse these many pages. If you take a look at the screenshot on the left, the page cache was generated for all of these 5-6 pages. Now, as soon as I go back to the system and add a comment to any of the nodes or modify any one of the nodes, the entire page cache gets purged. So the reason behind this was there was no way in Drupal to know that the cache for these pages are dependent on what. There was no way to effectively say delete all of the cache entities which are dependent on node/1 or node/2, which is being updated or deleted or edited. The third problem was there was no way to handle authenticated user cache in core. There was a contrib module which a lot of us might have used, auth cache. Now this provides a way to cache data for authenticated users as well in Drupal 7. But in core, there was nothing yet. So coming back to the previous point which we were discussing, there was no way in Drupal core to say delete all of the cached entities which are dependent on node/1. So let's say I go ahead and update my node with node ID 1. Any view, any page, any block rendering this node, the cache for all of these entities should get purged. There was no way of saying that. There were only ways to clear cache by specifying a specific cache ID or providing it a wildcard or deleting an entire all of the cache entries inside a bin. There's no way to say clear any cache content which is dependent on node/20. Now to fix this, Drupal 8 came with a concept of cache tags. Okay. Now before we move into cache tags, I'll give you a quick tip around Drupal 8 or something that has changed considerably in Drupal 8. In Drupal 7, you could render output as strings. So for example, you could write a hook menu and return hello world from it. In Drupal 8, you cannot do that anymore. Anything that's getting rendered on a page is supposed to be render array. Okay. So you can no longer return a string directly from anywhere. You cannot render a string directly. It has to be a render array. Now, why we're discussing this? Because this is one of the concepts which forms base around cache tags, implementation of cache tags. Okay. So let's see what cache tags are. Now, cache tags are nothing but they're just data dependencies. So as I said earlier, anything that's getting rendered on a page is going to be a render array. Okay. Now, Drupal 8 by default tags these render arrays with some values. Now, if any of these values do change, the entire cache for this render array should get invalidated. Okay. Now, the data that could be there in Drupal, it could be entities, it could be config, entity or config. If you were trying to write your own custom block or something where Drupal 8's cache tag, core cache tags are not sufficient, in that case, you can also introduce your custom cache tags. So if you take a look at the example here, we are trying to do something which is similar to cache set function in Drupal 7. In Drupal 7, we had cache set function in which we could pass a cache ID and a cache value, right? But in Drupal 8, we have a service for that. So use the cache service, tell it that I want to use weather bin, or I want to use cache bin, or I want to use views bin to store weather data with a cache ID weather_ind. Okay. The last array argument is something that's of most interest to us. So for example, if you take a look at this one where we have node:20 user:1 file:1 and weather_custom_tag. So these are the cache tags on which this cache ID is dependent upon. So we're saying that if anything related to node:20 or user12 or file1 or whether custom cache tag change, invalidate the cache tag, invalidate the cache data for weather underscore ind. So we'll see how it internally does that in a couple of seconds or couple of minutes probably. But yeah, you can tag your data with cache tags, and whenever these anything related to these cache tags change, your data, your cache data will get invalidated. Okay. Now another question comes around, do we need to write this cache, add these cache tags for anything and everything in the code? The answer is no. Entities or configurations, they come with the cache tags automatically. So whenever you're doing a node view, or whenever you're doing a node view, the array or the output which you'll get, it will already have cache tags with it. So unless you're doing something custom, you don't really need a custom cache tag. Okay. At the same time, if you're introducing a custom cache tag, it becomes your responsibility to clear that or invalidate that custom cache tag, because Drupal would not know about this cache tag, and neither it would know about when to invalidate this cache tag. Now, what invalidation is, we'll see in a couple of minutes, or how it happens under the hood. Now, let's say, so that was a small example wherein we were setting a cache key with some value. Now, we could add cache tags to our render arrays as well. And the process is pretty simple. So if you look at the screen and the code over there, it's a render array using some custom theme. It has some data, it has some attached libraries to it. In the end, it has a hash cache index. And inside that, if you see, it has a tags index, which in turn is an array holding a list of all of the cache tags this render array is supposed to be dependent on. So when we write a render array this way, or when we render a HTML corresponding to a render array this way, we say invalidate the HTML for this render array in case anything related to node 20, user 1, or whether custom cache tag changes. Okay. Now let's see what actually we mean by invalidation, or how Drupal 8 automatically invalidates the cache data. Okay. So this is a small flow diagram. Let's say we are visiting node/1. Okay. The first thing that would happen is Drupal will go ahead and look for a cached entry for node/1. Okay. It'll look for it inside a render cache table. That's where Drupal 8 stores the cache data for render arrays. Okay. It'll fetch 3 values. The first one will be the cache tags. The second one will be a calculated checksum, and the third one is the cache data. So it'll fire a query saying select tags, checksum, and data from cache render table, where cache ID is node:1:view or blah blah, whatever the cache ID be. Okay, so we have fetched the list of cache tags on which this render array is dependent upon. We have fetched a calculated checksum, a checksum value. Now for now, let's assume this checksum is nothing but an integer value. We'll see what this checksum is in a short while. And we have fetched the HTML data, which it had cached. Okay. The second thing that Drupal does is it stores all of the cache tags in a table called cache tag. Okay, with a integer value. Okay. The second step that Drupal would do is it will calculate a sum of all of those integer values for the cache tags fetched in step 1. So let's say we had node:20 and user:1 as cache tags fetched in step 1. Drupal will go ahead and query the cache tag table for the integer value corresponding to node:20 and user:1 and sum them up. Okay, let's call this value as invalidation checksum. Okay, or maybe let's call it as a calculated checksum. Okay, the next step Drupal would do is it'll compare the calculated checksum value with the checksum value that was stored in the database. Okay, if they match, in that case, it means that the cache is still valid. If they don't, then it means that the cache is invalidated. Okay, now what happens internally, or we didn't actually get to where the invalidation actually happened. The invalidation happens whenever you edit a node. So for example, let's say I go ahead and edit a node/1. Okay, Drupal will go ahead and update the integer value for node:1 and bump it by 1. So let's say previously the value of node:1, integer value for node:1 in cache tag table was 1, will become 2. The next time Drupal comes, a user tries to visit node/1 page, the value for calculated checksum and stored checksum would not match, and it would invalidate the cache. Let's take a look at it with a, we'll come to the slide after taking a look at this example. Okay, so this is the data that was stored in the database. We are taking an example of node:132. Okay, so the very first block, it has a cap. It has the list of column values for node 132's render cache. It has a cache ID, it has some data which Drupal cached, it has an expiration time, it has a create timestamp, serialized, and it has two other values, tags and checksum. Tags are cache tags on which the cache for this render array is dependent upon, and checksum is sum of integer values for all of these cache tags. So it's the sum of invalidation value or invalidation count of node 132, node_view, rendered, user colon 48, and so on. Okay, so whenever Drupal is trying to cache or store cache for a render array, it will go ahead and sum up the current values of all of the cache tags as a stored checksum. Okay, now let's say at this point the value for node:122 was 7. Okay, now the next step that I do is I go ahead and update node 132. Okay, what it does is it bumps up the invalidation count for node 132 inside cache tag table by 1. So now my cache tag invalidation count for node 132 becomes 8. Next time a user tries to go back to node 132 page, the stored checksum would still be 19, but when it tries to calculate the new checksum, it becomes 20, wherein the mismatch happens and cache gets invalidated. I think this example would have made more sense compared to the flow diagram. So yeah, this is again an example of what happened behind the hood when you edited node 1. So cache invalidate tags function got triggered with the cache tag as node ID, node:1, the cache name. And invalidate tags function, it does nothing, but it just bumps up the value of invalidation inside the cache tag table. Another important concept around Drupal 8 caching is cache metadata bubbling. So these cache tags, they are called as these cache tags or cache context or map expiry age of a render array. They're called as cache metadata. Okay. Now Drupal says that every parent would always know about what its children are dependent upon. Okay. So let's think of a normal page in Drupal 8. A page will be a render array in itself, whose children would be regions. Okay, and regions will have blocks as children, and blocks would have some other data as their children, maybe views, maybe nodes, or anything, right? So what we are saying by cache metadata bubbling is every region would know about all of the blocks, blocks which are its children, that what they're dependent upon. So let's take a very small example of this. This is a very dummy HTML of a page wherein you have two regions. First region, it just has one block. The second region, it has two different blocks, one block rendering a view and another one rendering a node, which in turn have, so each of these cache tags, each of these HTML tags could be considered as a render array in itself, which are dependent upon the values inside data cache tags attribute, right? So what Drupal says is each parent would know about what its children are dependent upon. So this cache metadata for, so for example, let's take the last block inside the second region. Now, this block, it has cache tags as block colon main content, but inside it, it has children's, which are nodes and fields, which are dependent on different stuffs. What happens with cache metadata bubbling is the cache tags, they bubble up to the parent. So every block would know about what its children are dependent upon. So let's say a block, if it's rendering a node 20, it would know that it would also, its render array would also be dependent upon node colon 20. And similarly, if the cache metadata is bubbling up from the children towards the parents, the root element obviously is the entire HTML. So the page render array would know about anything and everything that any part of the page is dependent upon. So let's say if anything on a page changes, Drupal is bound to invalidate the cache tag for the entire page automatically. You don't really need to do a cache clear or anything like that. Okay, so this is a very small example. Let's say we have a header, a simple Drupal theme in which you have header, first sidebar, second sidebar, a content region, and a footer region. The content region, it's rendering a view which is dependent on node 1, 2, 3. Okay, the second sidebar, it rendering another view which is dependent on node 5, 6, and 7. Okay, now let's say I go ahead and update node 3. Now the page cache is supposed to get invalidated, right? Because the page, the render array for the entire page, it has node colon 3 inside its data dependencies, inside its cache tags. But at the same time, each of the parts of the page are render arrays in itself. So what would happen eventually is the green parts which you see on the page will still get loaded from cache. The page cache will get invalidated and will be regenerated. While regenerating, Drupal will pull data for header from the cache, will pull data for first sidebar from the cache, will pull the data for second sidebar from the cache, will pull data from cache for footer. But when it comes to content, it knows that the content region has been invalidated because node 3 got updated. So I'll re-render the data only for the content region and not for the other regions. So it selectively can invalidate the cache only for the part which has changed on a page. Okay. Now the next thing that comes up is how do, I mean, Drupal obviously will work correctly with reverse proxies. By reverse proxies, I'm talking about Nginx or Varnish. I hope everyone understands what a reverse proxy is. So Drupal is going to work pretty well with reverse proxies as it used to do in Drupal 7. In Drupal 8, the additional advantage Drupal will have is the reverse proxies should be able to invalidate cache data once something gets updated in the Drupal system. Now, the bigger concern here is Drupal is a separate system and a reverse proxy server would be a different system in itself. And there should be a way in Drupal to tell the reverse proxy system that I have invalidated these cache tags. You need to invalidate any data that's dependent on these cache tags on your end as well. Okay. So the first step around that would be you'll have to go ahead and create a services.yml file and set the debug cacheability headers to true. Now what it does is it will start sending out another header with every page request with a list of all of the cache tags. this page is dependent upon. So let's do a quick demo around this. Luckily I have this demo setup with me. I'm gonna open this website over here. I'm gonna inspect the headers. Sorry. So if you take a look at my screen, you can see this the list of cache tags which this page is dependent upon is available in the headers. Okay, now it means that if anything related to any of these cache tags change, or if any of these cache tags get invalidated, Drupal should be able to invalidate the cache tag for the entire site. Okay, now my site, it has one content. I'm going to go ahead and create another content quickly. So I'm going to name it as dummy content for webinar dummy 1 and save it. This is node/1, node/2. Now, if the response is coming from Varnish, so I have Varnish set up on this instance, and if the response is coming back from Varnish, it will have a X Varnish cache as hit. The same applies to the second page as well. Sorry. Yeah. So right now, both of these pages are getting served from Varnish. Okay. Now, this means that even if I go ahead and update the title for this one, my webinar, whatever, updated, let's see, and I go back and hit this page in the browser, I'll still see the stale content, right? Because this is coming directly back from Varnish. It's not even hitting Drupal right now. Now, to fix this, in Drupal 8, there's a module called as core tags queuer and core tags purger. So let me just, yeah. So the purge module, which in turn gets integrated with a Varnish purger, and there's another module called core tags queuer. So whenever Drupal is invalidating a cache tag, it creates a queue and puts all of those cache tags in that queue as well. Okay, that's the responsibility of this module. The purge module with Varnish purger, all it does is it sends out a ban request from Drupal to the Varnish server saying, these are the cache tags which were invalidated on Drupal's end. Invalidate these cache tags on your end as well. Okay, so let's go back to the configuration, performance, purge, queue. If I inspect here, I have a few cache tags updated on my instance, but my node:2 is in the list. That's what's more important. I've been playing around with this website, so I have a pretty huge list of tags. But yeah, node:2 is here, which is of primary importance to us. So when I deleted, edited, or updated my node with node ID 2, it created a queue and put node:2 cache tag inside that queue. Okay. Now there are two ways to invalidate this cache tag. The first one is you set up a cron job and tell Drupal key execute a drush command and purge this queue. There's another way of manually doing it, which we'll do right now. Let me go to the website. Redox Drupal 7 brush p minus q minus work. So purge queue is the command, and there are a few issues with this module, and I had to debug it a little bit to get it working. But yeah, apparently it works now. Now I purge these cache tags. If I do a refresh here, my queue will be empty. At the same time, when I did a purge, it sent out a ban request to my Varnish server. So I've done nothing. I've just purged those cache tags. And now if I go back and hit this page, I'll see the updated title, which comes here. At the same time, if I go back and visit this one, now this request, it got served from Drupal database, not from the Varnish cache. But still, my previous page, which has not been updated, my node 1 didn't get updated. Oops, sorry. My node with node ID 1 didn't get updated in Drupal, and that's why for all reasons, the cache for this page should not get purged, even in Varnish. And it's still, I'm sorry, something went wrong. No. Okay. It should still come from Varnish. It's still coming from Varnish. So now Drupal cache system is intelligent and smart enough to invalidate only the cache which has changed or which has got invalidated. Okay. Now getting back to the slides. Okay. Now another important concept around caching in Drupal 8 is cache contexts. There's nothing to get much deeper inside cache context, but yeah, I'll give you a quick overview and cases where cache contexts are needed. So there could be cases wherein you'll need cache variation. So let's say you're building up a multilingual website. You'll want to have different variations of your node cache. So for example, your node/1 in English would have a separate cache entry, and your node:1/ French would have a different entry. In that case, that's the use case wherein you'll use cache context. To use a cache context is pretty simple. All you need to do is you need to add a hash cache index, and inside that you have to add a context key. And there are a couple of predefined contexts in core which you can use. So for example, in our case, we needed language, so we are using language context here. What it'll do is it'll create two different cache keys in the render cache table, depending whenever you hit two different versions of the same node in two different languages. Cache context, they are self-optimized, they are smart enough. So if you try to put in two different cache contexts, one of which is a superset of other, it will automatically create a cache variation only for the superset, not for the subset. The next one, which I think all of us are familiar with, is max age. Max age is the expiration age of the cache. It could have three values. If you want to set it to permanent, you set its value to -1. Fixed duration, it could be a value in seconds. If you don't want to cache a render array, you set its value to 0. Cache bins. Now, this is again another concept which used to exist in Drupal 7 as well. So you used to have a lot of cache tables, simple cache table, cache_data, cache_form, cache_views, blah, blah, right? Each of these tables were supposed to hold specific kind of cache data. The reason behind cache bins is very simple. If you try to store everything inside a single cache table, your cache table will grow immensely huge and will take more time to do a query in that cache table compared to doing a direct query. The same concept is there in Drupal 8 as well. So you do have a lot of cache bins. In Drupal 8, you have a way, you can define a cache backend for a cache bin. So you could say that your cache_data could go to memcache, and your cache_container data could go to Redis, while rest of your cache data stays inside the database table. In case you need to define a custom cache bin, all you need to do is create a new service via your services.yml file, give it a class mapping, add a tag it with cache.bin, and arguments are anything that this service is going to be dependent upon. Do a cache rebuild, and by default, the cache backend for a cache bin is a database. So you start seeing a cache underscore bin table inside your database. Now, to use a cache bin is pretty simple and something that we saw on the first or second slides, I think. Use the cache service. The first argument you give it as a bin name, and then a cache ID and a cache value. That's how you set it. And if you want to get a value out of it, you use the same cache service, do a get over it. I think this is probably the last part of the webinar. How do you handle the uncacheable content? So basically, when you say that something is not cacheable, you don't cache it. In Drupal, not in Drupal 8, maybe let's take a very simple example wherein there could be a part of the block which is going to be static, and there is a part of the block which could be dynamic. So let's say I want to create a block which generates the current timestamp with some text. So let's say we want to create a block something like this. Back to site. So let's say we want to create a block that is going to render this data. The current timestamp is and its value. Okay. Now, current timestamp, the value, it cannot be cached because it's going to vary very frequently, right? However, the static markup, the current timestamp is that text could be cached, right? So there's a part of the block which cannot be cached, and there's a part of the block which could be cached. Now, this is where the concept of lazy builders come into Drupal 8. We'll come back to this example soon. I mean, within a couple of minutes, actually. So what Drupal does to handle uncacheable content. Let's say when Drupal is trying to generate the generate the cache for a render array, it'll come across a couple of things which it can pull from cache. It will come across a couple of things which it cannot pull from cache. Okay, so when it come across something which it cannot pull from cache, it will create a HTML tag called as a placeholder. Okay, and these placeholders will get processed after the HTML with the cached content has been generated. So a typical placeholder will look something like this. It'll have a callback function name, like how should it resolve the content for this placeholder. Now, these placeholders, they are processed using something called as render strategies, which Drupal core has laid down. Now, since Drupal core has laid down interfaces to create render strategies, there could be contrib modules which can leverage these render strategies to process the placeholders in various manners. The default way by which Drupal does is called as a single flush strategy. Now, what happens over here is, as I said, entire DOM content will be built with cache content and placeholders first, and then the lazy builders are triggered and the callback functions are triggered to pull down the actual content for the placeholder, replace them in the placeholders, and then render the entire HTML to the user. So basically, even though the cached content is ready to be served to the end users, there's nothing that's actually visible to the end user until all of the placeholders are processed correctly. Now, this is the single flush strategy on which Drupal core works. Now, as I said, Drupal core also provides you with interfaces for render strategies. Now, that's what the Bigpipe module leverages to create its own n-flush strategy. Now, what is n-flush strategy? Now, in n-flush strategy, what Drupal does is it streams out the cached content to the end users as soon as it's ready. And it keeps on processing the placeholders in the background and stream the AJAX responses for these placeholders into the HTML. Now, the advantage around this, end user is able to see something or anything that is cached, anything that is pulled from cache as soon as it's ready, while Drupal continues to pull down the uncacheable content from the database. This reduces the time to first byte a lot, and obviously it enhances the user experience a lot. Now let's go back to the previous example, take a quick look at it. Now I'm gonna do a refresh on this page. Now if you would have noticed this, the text current timestamp was visible much earlier compared to the timestamp value. So this is the timeline. So it was visible at 2.38 seconds, while the actual value for the timestamp, it got rendered at 3.15 seconds. So the end user was able to see the data that was ready even at 2.38 seconds, right? Now, this is only possible because I have enabled Bigpipe module on my site. If I would have not enabled Bigpipe module, it would have looked like a normal rendering to you guys. And that's the advantage of Bigpipe. So you will be able to see the data as soon as it's ready. Now this is probably the code base around which, yeah. Now this is the important part. So if I take a look at the cached content for the block which I showed you guys, it will look something like this, wherein I have the static text, the current timestamp is cached with a placeholder, which gets processed whenever it's getting rendered. Now the question is, do you need to always define placeholders for things that cannot be cached? The answer is no. Drupal 8 core, it has auto placeholdering conditions. So any render array with any of these three conditions will always get auto placeholders. Get auto placeholdered. So any render array with a max age of 0, any render array with session or user context. So the default is session or user, or any render array with an empty cache tags array. All of these three will get auto placeholder. Now, the reason why I have kept session only over here is the default being session comma user, just to show you guys that you are free to update these settings based on your comfort, based on your application requirements. So you can choose to change the auto placeholdering conditions on your own based on your application needs. And I think that's pretty much around caching improvements in Drupal 8. I think I can take up a couple of questions if anyone has one. I hope I didn't bore you guys.
Yeah, you can ask. Any questions? Okay, so thank you so much for participating, and Piyush, thank you so much for this session. I hope if anyone will have doubt, you can reach Piyush through Twitter.
Yeah.
Either at 23.
Yeah.
Right? So yes, you can reach Piyush anytime with your questions in Twitter. So once again, thank you so much. And Piyush, once again, thank you so much for this session. It's always nice to have you here.
Thanks, Jaya. Thanks, Jaya, for the opportunity.
Okay. Thank you and good night.
Thanks,
Bye-bye.
all. Bye-bye.